Hello everyone, I am Dr. Serajul of Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about computational organic chemistry. So let us start learning with the introductions. Role of calculations. Calculations are much like experiments in that both may be employed in two different ways: data collections and looking for the unusual. So there are our target data collections and looking for the unusual. So what is the advantages of calculations? Why we are doing calculations? So answer of this question is, calculations can be performed on unstable molecules, which is not you will prepared in the laboratory, and the reaction transition state. Experiments are very difficult on such molecules and cannot be performed on transition state. So calculations are becoming less and less costly. Experiments are becoming more and more costly. So the advantages of calculations are safe. Experiments are sometimes dangerous. Calculations are now easy to perform. Experiments are sometimes more difficult. So calculations are now performed by not only computational chemist, but also experimental chemist after knowing some important clues. So always everything have some disadvantages, although a lot of advantages of computational organic chemistry. No doubt some disadvantage of calculations also there. The cost of calculation increases rapidly with molecular size. The cost of experiment is generally independent of molecular size. The calculations sometimes yield different results depending on the employed model. Experiment usually provide only one result. So basic guide to computational chemistry, like molecular mechanics method, quantum mechanics methods, semi-empirical, ab initio Hartree fog, ab initio correlated, molar plicet, and density functional. So differences between molecular mechanics and quantum mechanics. What is the difference between these two methods? Molecular mechanics are restricted to the description of equilibrium, structure, and conformation. Quantum methods also provide information about non-equilibrium forms. For example, transition states and about electron charge distributions. So molecular mechanics are based on use of experimental information, parameters. Cannot be applied outside the range of parameterizations. But quantum methods are not based on use of experimental information, and thus can be applied to areas where there is little or no prior experience. So molecular mechanics methods are much less costly than even the simplest quantum methods such as semi-empirical methods. So molecular mechanics, heavy atoms greater than thousands, semi-empirical less than 200, ab initio Hartree fog less than 50, ab initio correlated less than 20, and density function less than 100. Now relative computational time. You know computation time, for example, methyl cyclohexane, level of calculations, single point energy SPE, geometry optimization GEO. So MMFF94 level of calculation. This is the molecular mechanics. Single point energy F and geometrical optimization F. Now AM1 semi-empirical. You can see 0.06. Hartree-Fock oblique 3 to 1G ab initio. Sin Hartree-Fock 631G ab initio. MP2 631G star ab initio correlated, and density function theory. So, comparison of performance of molecular mechanics and quantum mechanics. Task geometry, satisfactory, semi-empirical satisfactory, ab initio Hartree-Fock satisfactory, DFT correlated satisfactory. Transition state geometry satisfactory. Now conformations unsatisfactory in case of semi-empirical, otherwise satisfactory. And thermochemistry unsatisfactory in case of semi-empirical, and other methods satisfactory. So references of MM and QM. MM means molecular mechanics and quantum mechanics. So widely used software package for MM or QM: KM3D, Cambridge Soft, Gaussian, Mopec, Fujitsu, Cybile, Tripos, Spartan, Wave Function. And each software has different user interface, operating feature, price manual, and so on. So application to investigation of molecular structure and property. Investigation of molecular structure by use of MM or QM. Geometry, absolute configuration. Investigation of molecular properties, electron charge distribution by use of quantum mechanics. So investigation of molecular structure by use of molecular mechanics and quantum mechanics, MM and QM. You know geometry, bond distance, angle, inertia of molecules. Conformational energy differences in 1,3 butadiene, investigation of order of stability. So S-cis, S-trans, and twisted. So relation between dihedral angles and relative conformal energy in 1,3 butadiene. You can look at here S trans, S-cis, and twisteds and their energy level. So absolute configurations: physical method, X-ray crystallography, and circular dichroism spectroscopy. Chemical methods like total synthesis, nuclear magnetic resonance spectroscopy, 2D NMR, 1D NMR with chiral derivatizing agents such as Mosher's method, and computational chemistry like molecular mechanics and quantum mechanics. So advantages and disadvantages of X-ray and circular dichroism method, CD. You know the CD, circular dichroism. What is advantage? These methods have high reliability. What is disadvantage? These methods have limitations of application. So preparation of single crystal X-ray molecules where pi electrons chromophore exist or can be introduced, circular dichroism. Now, advantages and disadvantages of total synthesis. This method has high reliability, disadvantage long time, many synthetic organic chemistry. So, advantages and disadvantages of NMR, 2D NMR, 1D NMR with chiral derivatizing agents. So, advantage NMR is widely used and easy to perform. Disadvantage low reliability on a cyclic system as well as macrocyclic system, 2D NMR, and preparation of derivatives by use of chiral derivatizing agent. So, advantage and disadvantage in computational chemistry. You know, advantage, this method does not require preparation of a specific sample in contrast to X-ray and Mosher's method. Disadvantage, this method requires combination with another methods such as NMR. So quantum mechanics has limited of molecular size. So determination of absolute configuration in a microcyclic system by a combination of computational chemistry and another method. Look at here. Sarcopene react with selenium dioxide at room temperature. Look at here the conversions, what happened here. HMBC and then NOC have different. Look at here, the distance between hydrogen 2 and hydrogen 13 is 4 angstrom in 30 R configuration. So this is not the consistent with the conformations, so R configuration. The distance between hydrogen 2 and hydrogen 3 in 2.4 angstrom in 13 S configuration. So CD spectrum, you can see CD spectrum. So investigation of molecular properties, electron charge distribution by use of quantum mechanics, electrostatic potential, atomic charges, dipole moment, enthalpy, entropy, and free energy, solvation energy, and investigation of basicity of proton affinity, acidity, and more. So, for aminopyridine, where is the basic site? Quantitative investigations, look at here. So, NH3 plus, you can see NH plus. So, which one is correct? So, B is more stable than A, and thus the ring N is more basic. Look at here, qualitative investigation, electrostatic potential map. Color near red represent more negative charge, while the color near blue represent more positive charge. So the ring N is more negative charge and thus it is likely to be more basic. So imidazole, where is the basic site? Look at here. N3 is negatively charged and thus it is basic site. So electrostatic potential map. This is very important. Now addition of alcohol. You know the pK, methanol, ethanol, 2,2-trifluoroethanol, phenol, and 4-nitrophenol. Weaker, stronger, weaker, stronger. So electrostatic potential map for alcohol. Look at here. Ethanol and now CH3 replaced by CF3 and either phenol and at para positions electron withdrawing group NO2. So electrostatic potential map shows the acidic site are positively charged and it reflects the relative acidities light versus dark blue. So when there are more than one reagent, which reagent will react first? When a molecule contains multiple reactive sites, which site will react first? So this is the challenge. So examination of frontier molecular orbital, HOMO and LUMO, is an important method because most chemical reaction involve electron movement between them. So this is the references. So examination of FMO energy, frontier molecular orbiter. A reagent with the highest HOMO energy will give its electrons most easily and thus be the most reactive donor. A reagent with the lowest LUMO energy should be able to accept electrons most easily and thus be the most reactive acceptor. So, acrolein BF3, what is the role of Lewis acid? So, Lewis acid are commonly used to accelerate the chemical reaction. The BF3, a duct of acrolein, more rapidly undergo nucleophilic attack than acrolein itself. So, look at here the structure of acrolein and acrolein BF3. So, HOMO energy and LUMO energy. You can see the smaller gap more reactive. A smaller gap more reactive nucleophile. So, Lewis acid complexation reduces the energy of LUMO on acrolein, making it more accessible to the HOMO on nucleophile. So, the regions where LUMO shape value is large will be reactive site towards attack by nucleophile. The regions where HOMO shape value is large will be reactive site toward the attack by electrophile. So, ester enolate, where is the reactive site? You know the ester enolate has two possible sites which may react with electrophiles, the anion and the terminal carbon. So look at here. So oxygen have negative charge and CH2E and here oxygen's E. The site where HOMO shape value is larger will be more reactive toward the attack by electrophile. The site where HOMO shape value is larger will be more reactive towards attack by electrophile. So the color near red indicate minimum value and the color near blue indicate maximum value of HOMO. So you can see here HOMO of the enolate and HOMO map of the enolate. So terminal carbon where HOMO shape value is larger generally react with electrophiles. So electrophilic substitution of indole, what should be favorite position for electrophilic attack? So HOMO map prevents that 3 position is the most likely site of electrophilic attack. So stereochemistry of nucleophilic additions to carbonyl compounds. Cyclohexanones has 2 possible phases which may undergo nucleophilic attack, the axial and the equatorial phase. Look at here. The phase where LUMO shape's value is larger will more reactive towards attack by nucleophile. Now, look at here LUMO map for the axial phase and LUMO map for the equatorial phase. So nucleophile preferentially attack from the axial phase. Now, LUMO map for the axial phase and LUMO map for equatorial phase. So nucleophilic preference attack from the equatorial phase. Now future directions. What is the future directions of this tech? Calculation in solution. Although calculation in gas phase usually provide a reliable account, it in solution is still unsatisfactory for the investigation of some task. So reference of recently developed method of calculations. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.